board before I forget. And now I'm ready to teach you a little bit more about functions, and then we're going to get started with animating stuff in Python, finally coming full circle, since that was something that was pretty easy to do in Scratch, right? Just making things move all around the screen. It will turn out to be a bit more involved with Python, but that will make it more rewarding, more fulfilling maybe. So that's exciting. Let's get started. Let's remember what functions are, because those are going to come up for the rest of our lives, and we'll go from there. So a function is a piece of code that you can call. It is runnable as many times as you want it to be run. You just keep calling it. That's what a function is all about. And they all have names, like you have to say def, and then you give the name of your function, call it func name or whatever. And it takes, potentially, doesn't have to take any if you don't want it to, you can just put a parenthesis to close it all off. But usually your functions take parameters, and those correspond to the things that you're passing to the function. Maybe this one takes two things. And those correspond to the arguments that are being shoved in here when you call the function. That's the correspondence there. So the arguments fill in for the parameters, then you put a colon, then you tab over, and you put the body. Whatever you need to do to accomplish whatever func name was supposed to do with these values that it's given. And a lot of the time, you have a function that needs to compute something and give an answer back. If you want to give something back, you use the return keyword. You say return, and then you say what you want to give back, of course, put whatever you want there. So return gives something back to the user who called you, gives something back. That's a weird E. Gives something back to the user, to the caller, let's say. I would say that's a better idea. And so, because then once it gives something back, you can use it in a larger expression like this, like func name 4243 plus 1. So the 4243 part will get filled in with whatever gets returned. So usually functions that return things, you need to you can use them in a larger context and be like func name 4243 plus 1. But then you got to do something with it. Like this has made an answer, you've not printed it yet, so maybe you can call print on this giant result, or at the very least, save it for later. That's the goal. That's in contrast to functions that don't return something, maybe a function that just prints something. Those functions that don't return anything are just meant to be called in a line by themselves. Func name 4243, that's a different kind of function. This is if it were to have not returned something. And some functions don't return anything, like turtle.forward. Doesn't give anything back, it just tells the turtle to move. You call it on a line by itself. Right? So remember the difference. Some functions just do things, they don't need to return anything. Some functions give an answer back, and you better use it. So that's the concept of the print function prints something. You call it on a line by itself. It doesn't give anything back. Versus using math.square root. Calling math.square root on a line by itself makes no sense. You have to use it somewhere. You get that answer back. Do cool stuff with it. So that's functions review in a nutshell. Any questions about that? It's all coming back to us because I will be writing some functions today, and we just got to understand them. All right. So with that, I am going to write some Python. So I'm going to open up idle just to get ready. If it wants to open. There we go. All right, so let's combine turtles and functions. I'm going to write a function that draws a rectangle on the screen, and we want to call it draw rectangle. And then the question is, this needs to take arguments because we need to specify how to draw the rectangle. What does it mean to be a rectangle? How do we represent one? What does it mean to be this exact rectangle right here in the coordinate system? That's a very philosophical question. But if you think about it long enough, one way to represent a rectangle is to give the coordinates of all four corners. Right? That's one way to specifically specify this exact rectangle on the screen. Another, maybe slightly more efficient way is to give one coordinate, like this is 1, 5, and then give the side lengths, 3, 4. You can still compute the coordinates from those three pieces of information still, right? So I think that's the best way to go. So let's represent a rectangle by like one of its corners, the coordinates for one of its corners, and then the width and height of that rectangle. That will tell us exactly where it should be. That represents uniquely any rectangle on the screen. Okay? So that's the representation. And so we need to like have our draw rectangle function take some parameters. It needs to take a starting coordinate, and then a width, and then a height. So maybe it needs like 3 parameters, something like that. Maybe I need a third question mark. And I want to teach you how to pass along a giant coordinate. So I told you about lists before. One way to package together two numbers like the 1, 5 is to put it in a list. Right? That's the type of that. When you use those square brackets. There is also a similar concept where you use parentheses. Instead of those angle brackets, put 1 and 5 between parentheses. That is also, it looks more like a coordinate there, so we prefer it. That's a different kind of thing in Python. That's called a tuple, the type of 1, 5. That is called a tuple instead of a list. All right, so here is an example run on the REPL of this, but a tuple is just a bunch of numbers between parentheses, or a bunch of anything between parentheses with commas to separate things. You can assign those things into a variable. It's very similar to a list. A tuple is pretty much a list, except you can't mess with the stuff inside. So you can save 1, 2 into a single variable. That's good, because we want to represent coordinates as one big thing. And then when you ask for it again, it's been saved away. It's the whole thing. It's the 1, 2. The tuple 1, 2. So the type is called tuple, and you can extract stuff from a tuple. You can be like, what's x of 0? That was the coordinate 1. What's x of 1? That was the coordinate 2. So remember that the indices start at 0 still. The only thing you can't do, let me like put 1, 5 into x again, so like x 0, you can get it out, x 1, you can get it out. The one thing you can't do with a tuple is change, like you could with a list. With a list, this is fine. This line would work. But with a tuple, everything is immutable, we say. So you cannot change stuff that's already inside of a tuple. You got to make a new tuple. All right? So that's just a new data type, and it's very similar to a list. But that's the type of thing that we will use to represent a coordinate, because it looks just like a coordinate. All right? So that's called a tuple. And with that, we can make our draw rectangle function. So our draw rectangle function, and we already talked about what parameters it's going to need. So we're going to represent our rectangle with a starting coordinate, one of them. Let's just hard code it, or let's plan on taking the upper left coordinate always. So these needs to give us an upper left coordinate, and then width and height. So we've talked about this now. What parameters should draw rectangle have? When I define it, def draw rectangle. It needs 1 point at least, like say where something is in space, because otherwise, like, this rectangle is the same width and height as this rectangle, but they're in different places. I need a point to, like, say this one, its upper left is here, this one's upper left is here. So I need that. We use the upper left coordinate, and I'll call that UL, the coordinates of the upper left corner, given to me as a tuple. And then I need to know, like, how wide and high the rectangle should be. So I'll pass along the width and the height into other parameters. So that's going to be the start. And we're going to use tuples to represent the coordinates. They're those things with, it's essentially take a list and replace everything with parentheses. And maybe once we do some more, we can add a color parameter to make a rectangle of a certain color, because turtles know how to draw things of certain colors. But like, what's going to be the body of this draw rectangle? It's going to be like, well, go to UL. Tell the turtle to go to the UL coordinate, ... and then like face right, and like go forward by the width, and then turn right, go forward by the height, turn right, go forward by the width, turn right, go forward by the height. Do you see how everything that I put up here is all that I need to draw that rectangle? It's pretty cool. So the way that I will pass along this particular silly example rectangle now with 1, 5, 3, and 4 is I will call draw rectangle. On a line by itself, it doesn't return anything, it just does something for me. I'll call it with the starting upper left coordinate 1, 5, the width 3, and the height 4. So that's how I will call it. All that's left is to implement it. There's a few things to do there, though. All right. So any questions about the setup before I code up this draw rectangle function for us? All right. So I will make a new file, and I will save it in a folder for today. Today is lecture 24. On the desktop. So I'll call this draw rectangle.py. And now we can go back to the slides. So what do we need? So again, we want to use our draw rectangle function like this. We want to be able to say something like draw rectangle starting at 50, 100. That's your upper left coordinate. Draw a 200 by 300 rectangle, please. Something like that. And so now we have to implement the draw rectangle function. We need the turtle library, so let's import turtle. Let's make sure the turtle looks like a turtle, like I like to do. Turtle.shape, give it the string turtle. And then now, draw rectangle, def, draw rectangle. It's going to take the upper left coordinate, the width, the height. And then the body is going to be, well, what do we need to do to draw this rectangle? We need to move the turtle to the upper left coordinate, because that's pinning us down. That's where we need to be to start. Then we can draw from there. So move to UL, face east or right, go forward by width. That'll give us the top. Then turn right 90 degrees, go forward by height. That'll give us the right side. Turn right 90 again, dot, dot, dot. I think you get the idea at that point. All right, so let's do this. Let's move the turtle to UL, making sure to pick him up before we move him, because otherwise I'll make a mark from his starting position. Turtle.goto. Go to whatever is in UL. That's totally fine. That would work. Alternatively, I guess technically, here's what you could do. Let me show you the turtle library. We'll get some practice using tuples. Python turtle. So remember that turtle.goto takes the coordinates that you want to warp the turtle to, and technically it takes it as an x and then comma and then a y. UL is just one big thing. UL is the whole thing. UL is equal to 1, 5 or something. So how do I get just the x out? It's going to be at UL of 0. That will give me the x coordinate, comma, the y coordinate is at UL of 1. Index 1 gives us the second thing, the y coordinate. So that's one way you could do it. You could just pass along UL. It understands. But this is a good practice for us extracting things. What next? All right. So then the turtle needs to be ready to make marks now. We need to say turtle.down. It's we pick him up, we warp him to where he starts, and now we want to draw a rectangle, so we need to put his tail down. And then we face right, which is turtle.set heading and 0. That's apparently the default direction is right. Then we want to go forward by width. So turtle.forward, how much? Not 100, not 200, but whatever is stored in W, whatever the width is. And then turn right 90, turtle.right 90 degrees, then go forward by the height. And then we need to do the rest, but let's watch it work for now. Cool. Let's try that again. Yay. And so what still needs to happen? We need to turn right again by 90, go forward by width. And then 90 once more, forward by height. It's always turn right. we are. And so that is me drawing one rectangle with the starting coordinate of this, width this, and height that. Should make enough sense. Any questions about that? The beauty of this draw rectangle function is that I can call it as many times as I would like. I can make a draw rectangle call right after this to draw another rectangle, a second rectangle. And it can start at, I don't know, negative 50, negative 100. And it can be tiny. It could be like 50 width by 30 height, something small. And then again, we'll jump to the code that we wrote. There's the first call. Then it's going to call the second one. And so the UL in the second time, it's going to be set to negative 50, negative 100. That'll be set into UL the second time we jump up here and we call. Then the width will be, W will be set to 50, H will be set to 30. We kind of see how that's going to work. Any questions about that? That's the whole point of making functions. All right. So with that, let's make it slightly more fancy. Let's add a color parameter so that we could say something like this. I would like this rectangle to be outlined in black. I would like this rectangle to be outlined in red. So I'll add another parameter because I'm passing along another argument. I'll call it color. And how do you set the color of what the turtle's going to draw, the outline color? It's turtle.pen color. Set it to whatever is stored in the color variable, whatever the user passed to me. If it's black, make it black. If it's red, turtle.pen color red is what happens. So the first one is black. The second one is red now. It's not fun. And you can do it one last time if you want. Let's see here. We can say draw a rectangle right in the middle, 0, 0. And it can be a perfect square, 75 by 75. And let's make it blue. So now I have 3 calls to my function. Cool, I can show it all to you. So if I rerun, draws the first one, draws the second one in red, draws the third one in blue. Yay. Any questions about any of that? So we made a function that is very helpful to us. We don't have to duplicate all that work. We just put all the code that we care about up in that function, and it handles the rest. Okay. For my next trick, I would like to make another function that uses turtles. Let's make, you know how I made you hard code your initials and stuff? You did your initials and then your graduation year or something. Let's make functions for each letter. Let's make a draw L function kind of thing so that we could specify, I want this L drawn right here in space, or I don't know. Here's the idea. I want to make a function that draws L's at a starting point with a certain width and height. So I could draw one way up there, I could draw a skinny one way down here. What are letters but pretty much rectangles? So if I make it very similar to my draw rectangle function, I can make a draw L function pretty easily. See that? Because here's the bounding rectangle of this L that I care about drawing. It again has an upper left corner, it has a width, it has a height. And so I can make a draw L function just as easily as I could make a draw rectangle function. And then I can call it multiple times to draw different L's of different widths and heights and starting points. So this one has another coordinate, has a smaller width, maybe a bigger height than the other one. That's kind of nice. I can make one function that can draw as many of the same letter as I would like. So that's my next goal. So let's make a function that, because I used L as an example, let's make it draw my other initial. Let's make it draw an N. And the trick is always, every letter that you want to draw, it's secretly a rectangle. You can at least bound it inside of a rectangle. And from there, you can draw whatever letter you care about. So given your rectangle that will fill up, borders the letter, you can draw your character with that width and height and starting point. So I don't know, here's what it would look like to draw an N in this rectangle. Like it's got an upper left, it's got a width, it's got a height. I think you can imagine what needs to happen, like figure out the coordinates, go to here, all that stuff. And then I can call it multiple times. I can make a very skinny N that has its own upper left and its own width and its own height. And I'll pass those along, and it'll draw it like this. That's pretty cool. And so I'll make a draw N function. I'll say def draw N. And what do I need? What's all the knowledge that I need to draw the N that I care about? I need its starting upper left coordinate, I need its width, and I need its height, just like for a rectangle. And then it's my job to fill in the body, of course. So, that'll be nice. Let's do that. Let's do a draw N function. So make a new file, very similar to my other one. Draw n.py. I'll paste what I had before. We're going to get rid of the color. Let's see. I'll just get rid of all of this. And then maybe I'll keep these calls. But instead of draw rectangle, we're going to call it draw N. And then I'll have you try your own initial in just a second. But again, the goal is this perfectly represents exactly the N that I want to draw each time. It's like, here's its upper left coordinate. From those, and this width and height, draw the N that I'm telling you to draw. So what's the process got to be? Well, UL holds some coordinate. That's my upper left coordinate. I'll call that X and Y. I need to go there first, just like I was drawing the rectangle. But I can't just like turn right and go forward anymore because N's don't look like that. I need to have the turtle do something in a very certain order. I need to actually start the turtle, not at XY, but like down here. So I can then go up, draw that line, then go over, and then go up again. And that will be the N of my width and height of choosing. So honestly, it's just going to end up being a bunch of go-tos. I need to figure out this coordinate, then I need to go to this one, then I need to go to this one, then I need to go to this one. So I need to figure out all 4 coordinates of this rectangle. And we have all the pieces, so let's do that. What is this coordinate? What does it got to be? It's got to be the same x, right? It's the same x as this one here. This is xy. It's going to be the same x. Oh no, there it goes. Same x, but the y is lower. So it's not this y, it's this y like shrunk down, taken down in the negative direction by h, less y minus h. See that? That's got to be the coordinate for this part down here, assuming the xy was the upper left. And then, what's this one got to be? Well, it is not the same x coordinate. It is more to the right. How much to the right from x? It's width more to the right. So this x coordinate over here is x plus w. But the y is the same. It's still up here on this line, so it's still y, x plus w comma y. See how I'm calculating that? I believe that you could do the same. And then finally this one, the x is x plus w, like we said. And then the y is not this y, it's down here again, so it's y subtracted by h. So those are my 4 coordinates. If I just go to those in the right order, it will draw the N that I care about, at least. So here's the code. Let's make this smaller so I can show everything. And so what do we got to do? Well, first of all, we need to get the x and y out from UL. Remember that UL looks something like this. It's like UL is set to like 1, 5 or something. So UL of 0 is the x, UL of 1 is the y. So x is equal to, let's pick out the UL 0, the 0th part of it. The y is the second thing, which is index 1 in UL. And then after we have x and y, we draw a w by h n character. And what's our starting coordinate? It's not xy anymore, because I got to draw the n from the bottom, right? It's got to be down here first. And so this is where I start. I start at xy minus h. So start at x, y minus h. And so that's where I got to move the turtle to first. So turtle dot go to x, y minus h. But we got to remember to pick the turtle up so that he doesn't make a mark on his way there. Otherwise, I'll draw an empty line, a very weird looking line. Turtle dot up. Turtle dot go to. Now you're in the right spot, turtle. Turtle dot down. And then that guarantees we are here. Next we go to xy. Next we go to x plus wy minus h. Next we go to x plus wy in that order. And so it'll draw the end. xy, then let's just copy and paste this. Then it's going to be, oh, did it not copy? Then it's going to be x plus w, y, oh gosh, y minus h. And then finally, x plus wy. That's the order of all that stuff. That's what we noticed we needed to do. And so now I've got my function. Here I am calling it 3 times. Let's watch it work. So it draws that one, and then that one. A lot of ends. Any questions about how this worked? So again, we're packaging this generic way of drawing ends into a function. Given an upper left starting coordinate, we're calculating all the other coordinates, and we are drawing what we set out to draw with that particular width and that particular height. And so here's 3 calls to it, and of course you can make as many as you'd like. Good with that idea? Functions, very powerful. All right, so with that, assuming we're happy, your turn. So please take this code. Here it is. Change it to make like a resizable L character or some other character that's in your name. So instead of a draw n function, make a draw L or make a draw A, B, C, whatever you like. All right? And call it a few times, get some practice. So here's my code, and I'll give you a few minutes to try that. We've got plenty of time. And please yell at me if you have any questions about anything. couple more minutes. If you finish early, maybe you can try drawing like 50 of your characters at random spots. There's my timer. Did any questions come up as you tried this? Hopefully you got a letter working or almost working. Feel free to take more time afterwards to get it working. It is a good thing to practice, I think. But I think I am ready to do the final piece of today. One last thing I want to show us. One last main example. I would like to talk about animation now. So I'm going to make the simplest animation I can think of, was just like a circle representing a ball dropping and bouncing. So that's like going to be our game plan. So this is the animation that we're going to write. It's going to be a ball, and it's going to start somewhere like up at the top, and then it's going to start moving. It's going to move that way, then it'll bounce off the bottom and like move back up, and it'll just like pretend there's zero gravity. It'll just bounce up and down. That's going to be the program that I want to write for you next, and let me show you how to do it. It's going to be our first taste of animation. We have not animated anything in Python yet. So let's talk about animation, because we kind of have to like hard code what needs to happen. It's not the same as Scratch, where it's like it's very easy to have things move and redraw themselves and things. We want to make animation. We have to do it the hard way in Python. So let's think back to and remember what animation really is. So animation, on a screen at least, is just moving pictures, right? If you go back to the old film reels, all film was, all movies were, is just a bunch of images flashed into your eye really quickly. Maybe like 24 pictures per second or something. Those are called frames, right? So it's a bunch of still images shown to you very fast. That's all animation is. And so we have to draw each animation. We have to draw each image called a frame if we would like to make animation in Python. So for example, maybe you made a flip book before, like in elementary school. That was something that I did. If we want to draw a bouncing ball, we have to draw each individual frame. We have to draw a frame where the ball is at the top, and then we have to show that to the user for a while, and then we have to draw a new frame where the ball is moved a little bit down, right? Because that's going to give the illusion that it's falling. If we draw another frame where the ball is moved even more down, we just show these to the user in rapid succession, and that produces animation. These are your frames. And everybody like wants to play video games with the best frame rate. All a frame rate is, if we're not familiar with that term, is when the images change faster, you get a faster frame rate, we say. And so it's supposed to look more natural, more like real life, because everything's perfect with our eyes in real life. Things are actually moving there. So yeah, if you have a fast enough frame rate, it tricks your eyes to thinking that this thing is really moving rather than stuff like that. I think Movies, for example, are standard. Their standard amount of frame rate is 24 frames shown to you per second. So 24 frames per second. So every 1/24th of a second, a new frame gets shown to you. Most video games these days like to be at 60 frames per second to be considered playable. So yeah, that's the idea. That's animation in a nutshell. And if we would like to make an animation of a ball dropping, we have to make each individual frame and show them to the user for a split second. That's what we got to do now in Python. And we'll use the turtle library, of course, to draw these individual frames. But that's about as much as we can do with that. Right, so we're going to make a new file. There's going to be a lot to have happen here. So let me think about how I want to explain it. I'm going to eventually write a draw frame function. I've promised to do that, apparently. Let's see here. Here's the goal. Let's make, when we have our turtle window pop up, I guess the window itself is like your viewing window, but let's pretend like we're drawing a screen inside of that. So let's draw a little bounding box for where our ball is going to bounce on top of, because if you have a bigger screen, like your window is more zoomed out, and so let's just keep it the same for everybody by drawing a bounding rectangle for our viewing window. Have it be a bounding square, maybe. So I think the very first thing I want to do with this ball dropping game is to make a 400 by 400 rectangle, and that will be like our window in which we will draw things. And we want this to be centered in our screen. So like at 0, 0. So what is this upper left corner? Because we're going to use the draw rectangle function to make this. It's going to be negative 200, positive 200. So that's that. And this will be like our little viewing screen where this will be like the walls that the ball could bounce off. Right? So that's our bounding square. And let's get that at least. Oh gosh, so I do need that file that I accidentally closed. Draw rectangle. So I want this draw rectangle function actually. I'm going to steal it, put it in a new file called bounce. So I need the draw rectangle. It does not need to have colors. It'd just be a black rectangle is fine. That's okay. And I would like a bounding rectangle to be at, what was it? Of course, there's a million other things open, sorry. I'd like to have its upper left to be negative 200, positive 200, and then width and height 400. It'll be a bounding square, really. And so that's just me using my draw rectangle function. Got rid of the color, though, so let's get rid of that. There. And so this is going to be our bounding square, which is just going to be the walls that the ball will bounce off of. And that will keep us all on an even playing field. So it's just going to do that. That draws, so this is like the window, and the ball will like start at the top now, and we'll have it bounce down. That's our goal. But that's what draw rectangle did. And now, what else needs to happen? All right, so we need to put a ball here in the screen, and we need to put it at the top. Ever so just gently touching the top. Then we have to have it move down, hit the bottom wall, and then bounce back up, and just do that forever. Up and down, up and down, up and down. Same y coordinate, same x coordinate, just different y coordinates. So, yeah, let's figure this out. So the next secret is going to be that we need a circle here, and we can actually draw a circle with the turtle. We can turn the turtle into, like, one of the options to change that. Like, the turtle starts out as an arrow. I said turtle, that shaped turtle. But secretly, you can make the turtle other things. Turtle.shape could be circle. So we're going to make the turtle the ball. So that's the first trick. We're going to make the turtle the ball with turtle.shape. And it's got to be in quotes. It's got to be a string. What do you want the turtle to be? And then, what will that do? So there is my turtle. He is now a circle. That's kind of cool. And it just so happens that the fill color of the turtle determines his color, and so we can change his color by changing the fill color. We'll just use him as a circle, though. We won't ever draw anything else. Turtle.fill color, make it, I don't know, pink. That's apparently what I did last time. And then he's a little ball. You can make him a bigger ball if you'd like. There's a size to the turtle. It's turtle.size. It's somewhere. Yeah, turtle dot. How did that change? Let me just search for it. Okay, yeah, it's called turtle size, and you can stretch them along the width axis and the length axis. We want to stretch them across both so he's still a circle. Otherwise, he'll be an oval. And we'll say turtle size, like make him twice as big in each direction. Two times the width, 2 times the height. Now he will be a slightly larger circle wherever he is. There we go. That's a decent sized ball. And now we just got to put him in the middle over there. All right. So there's a lot that we have to worry about here. Gosh. We need to put the turtle in the middle, and then we have to move the turtle ever so slightly every frame. To make this easy for us, let's keep track of where the turtle is, because the turtle is the ball, right? Let's keep track of where the turtle is with variables. Let's keep track of the turtle's x-coordinate, where we want him to be. Let's keep track of the turtle's y-coordinate. If we want him right in the middle, like here's 0, 0 right here, we want the turtle like a little bit up here, like almost at 0, 400, right? So the turtle's x-coordinate should always be 0. He's just moving up and down along the x equals 0 line. And then the turtle's y is almost 400 to start. It's like 400, but that'll like put him up there. I'll show you the problem. And then that should help, right? That's almost the right answer. So we got to move the turtle to where we want him to be at the start. So let's do that. So we're going to make a bunch of variables here to keep track of like where we want the turtle to be. We'll use the variables. We'll use these variables that I'm about to type to keep track of where the ball should be / where it should move to. So these variables are going to be like our ground truth of where we want the ball to be in our animation. So turtle's x should start out at 0. The turtle's y should start out at like 400 or something. It's 200, excuse me. And then like that's where the turtle needs to be. So let's move him there with goto, because it's what goto is actually what moves the turtle. Yeah. So it'd be like turtle, put the turtle in the correct starting location. So turtle.up, of course, because we don't want to make any more marks. And then like turtle.goto, you're where you're supposed to be. Your x, turtle x, that's what I'm saving in this variable where I want his x to be. Turtle y, I'm saving there where I want his y to be. And so that is actually going to be the line that moves the turtle, but these variables will be what we use to keep track of where we want him to be. So there's my bounding rectangle. And then I've moved the turtle to be right here. 0, 200 is the coordinates, but you can see that he's outside the bounds of the wall, which is unfortunate. It's always relative to his middle. So if we want the turtle to be just so touching, like the very tip of him at the top touching the wall, we have to move him down a little bit by half his height. Half his height, okay? That's the goal. So like he was here, we got to move him down by half of that height right there. That's the idea. And so, let's see, so it's not like turtle y is 400. Sorry, it was supposed to be 200, first of all. Oops. Whatever. Turtle's y should start at not 200, but 200 minus, like the width of the turtle over 2, or the height of the turtle over 2. He's a circle. His radius over 2. I'll just say width. So I did some digging, and apparently at the beginning, the turtle is 20 units by 20 units. And so when I stretch him by 2 in each direction, his new width is 40 units, maybe it's pixels, I don't know, whatever the turtle library is using. So what I want him to do now is to start not at y equals 200, but y equals 200 minus half of your width, Mr. Turtle. And so this is now very nice and generic, and you could change this to be different things. And that's going to rein him down to be where I want him to be. That's the starting point of the turtle. Cool. So now he's at the top. He's at the top of this window. And now our goal is going to be produce animation. Move him a little bit, redraw him. Move him a little bit, redraw him. Honestly, that's all taken care of by the turtle.goto. You remember that? So if I say turtle.goto, go somewhere, it takes a hot second for the turtle to move where I told him to go to. Like he just like warped to the side and there was some animation there. So we're going to hook into goto to animate the turtle. We're going to move him just a tiny bit and use goto to get in there. That's going to be our goal, right? That is how we make our frames. We're going to move the ball ever so slightly each frame. And that involves changing the y coordinate, right? Because the turtle's x is always going to be up, down, up, down, up, down in the same spot. But the y is going to change, like get smaller y, smaller y. So like the next ball that I should draw is maybe like right here or something. That'll look like he's moving. It's like go to there. And so every round of frames, I need to make the turtle's y coordinate just a little bit smaller. And so I need to repeatedly move him down, change his y, make it slightly smaller, and tell him to go there. That's going to produce animation. And so I'm going to use a variable called turtle offset. For that, I want him every frame, every time I use goto to make him like animate himself, I would like him to move maybe like -5 units down. I think that's a good amount. And you can change that. This will actually affect the speed, so that'll look cool if you change that. But the goal is going to be like repeatedly now. Repeatedly, please, Mr. Turtle, change your y, turtle y. It used to be up high, make it smaller. So it equals what it was, plus that offset, because the offset's negative. Turtle offset. And then actually tell the turtle to go to his new position. Like the x is never changed, but the y is, and so like make him move there. Redraw the turtle, which is going to be a call to go to. Right? So that is going to be pretty much the setup. Gosh, what do I want to do? So turtle offset. I'll put that here. Turtle offset. We'll make that -5 or something. And now repeatedly, I would like to repeatedly move the turtle a little bit and do stuff. And I'm going to do that in a function. So I want to make a, here's my animation. That's like forever, while true. Please repeatedly draw a new frame. And so I'm going to make a draw frame function, and I'll just call it. This will take care of, like in this function, it will take care of moving the turtle a little bit, redrawing it. Just to get us some practice with functions. All right, so let's make that draw frame function now. Figure out what it needs to do. So every time I call this, takes no arguments, I am going to change the turtle's y coordinate by the offset, and then redraw the turtle. Yeah, those are the two things I need to do right now. So turtle y equals turtle y plus turtle offset, and then redraw the turtle, which involves saying turtle.goto is his new coordinates. So turtle x, which didn't change, and then turtle y, which did change. All right, let me put we changed it right. So repeatedly, the while true does that. Repeatedly draw a new frame, which jumps here, changes the y, and redraws the turtle. All right. But here I am setting a global variable. Y is defined outside. Turtle y is defined outside. I'm changing a global variable inside of a function, and Python doesn't like that unless I alert it that turtle y is not meant to be a local variable. It's meant to be a global variable. Please use it. Right? So global turtle y is what I got to say if I want to change a global variable inside of my function. That's just a quirk of Python, but the rest of that's going to work. So yeah, repeatedly draw a frame which is going to change the turtle's y to be something a little bit smaller because the offset's negative, and then tell the turtle to go to there, and that takes some time, and that will produce some amount of animation. So there's the bounding box, and there's the ball falling. And now it's off the screen because it just keeps going down forever. And you can change this offset because this is how much he moves every frame, right? Every time I call go to, change your y by -5. If I say change your y by -2, that's less each frame, so that'll be slower. And of course, it opened in a window where I couldn't see it. But here's that. There's the code again. There you go. It's falling gracefully now. Maybe I'll keep it at -2, but you can change that to whatever you want. Are there any questions so far? Because now, of course, the turtle's fallen off the screen. That is a bit of a problem for us. We still all right? So yeah, that's more or less the end goal. What we need to do now is when the turtle, like we're changing the y-coordinate to be a little bit less each frame, but we also need to like check, hey, turtle, did you just hit a wall? If so, I want to bounce you off. So like when the turtle gets way down here, I need to notice that, first of all, with an if statement or something. And then I want to change the turtle to be moving up instead of down. And that's going to involve changing the offset to be not negative anymore. I want the y to increase now when the ball moves up. So the offset won't stay negative. It will sometimes flip over to be positive. That's the idea. And so the offset, we're going to be using that to be direction for us. It's going to represent our direction. Direction. That's pretty cool. When it's negative, we cause the turtle to move downwards. When it's positive, that causes the turtle to move upwards. That's pretty cool. So, all right. We need to add some checking now. If we hit a wall, bounce off that wall. So now the question is, when do we hit walls? What is true about the turtle when we hit a wall? Like when we're up here, when we're down here, what is true about the turtle? It's all about the y-coordinate, right? Because when the y-coordinate was exactly 200, the turtle was like a little bit over the wall. And so if we check that it's within the range, like it definitely can't be bigger than 200. It shouldn't even be equal to 200. The most that the y could ever be is 200 minus width over 2. If it's ever bigger, we've like shot off past the upper wall. And a similar concept is true about the bottom wall. This is going to be, like here was 0, 0, right? So this is like negative 200. This right here, just touching the wall, would be negative 200 plus width over 2, right? This amount, like go forward, go up a little bit more. So if the turtle is just ever so touching, grazing the bottom wall, that means his y-coordinate is negative 200 plus his width over 2. I hope that makes enough sense. So if the turtle's y, like if the turtle's y is equal to, right, the negative 200 plus the turtle width over 2, he is just perfectly touching that wall. But maybe the offset made us like skip over that. So if we ever try to put the turtle like at this spot or even lower, like we've accidentally with our offset, maybe our offset's like 10 or something, like he used to be here now, and then he jumped to be way down here. If the turtle ever, his y-coordinate becomes less than or equal to this amount, negative 200 plus the width over 2, that's just grazing the wall right there. If that's ever true, either we perfectly hit the bottom or we tried to exceed it. Right? So we either, if we're here, if this is true, we either hit the bottom wall or we're trying to go below it. Either way, it's time to change. So what we want to do is potentially the turtle went outside. So we want to move the turtle back inside, first of all. Move the turtle back inside, which means make it exactly graze that bottom wall. So set as y. It's not already exactly this, like maybe it was smaller, make it exactly this. And then make sure that in the future we go up, because we just hit the bottom wall. Change the offset so we move upwards now. And I don't know what the offset was. It used to be -5. Now I say it's -2. So just change the offset to be whatever it is negated. So multiply it by -1. That'll make -2 +2, -5, +5. That's our goal. So just change it. Multiply it by -1. Turtle offset equals turtle offset times -1. That is what we do if we hit the bottom wall. And let's see here. Not all that I wanted to say. Oh, turtle offset. What is that but a global variable? So if I want to change that inside of a function, I have to shout that out to Python. There we go. Turtle offset. So now repeatedly draw a frame. What does that mean? Change the y amount by a certain amount, given the offset, whatever it is. And then, if it's ever exceeding this amount, if it's ever trying to go below the bottom wall, rein the turtle back in to be just grazing that bottom wall, just exactly touching it, and then make the offset negated so that now we move upwards. Because we were moving down to get here, we've got to move upwards now. And so here, is it running? So once it hits the bottom wall, it's like, whoa, bounces up. And now it flies off into outer space because we're not checking the top wall. A very similar thing needs to happen now for the top wall. So we don't want the turtle to ever exceed what? We don't ever want the turtle to exceed, what was it? What is right here? It's 200 minus his width over 2. That's the largest the y should ever be. All right? So if it's ever that or bigger, we do the same thing. All right? It doesn't have to be it could be an elif, but I'll just make it 2 separate if statements, because why not? If the y is ever trying to go past the top, so if it's ever greater than or equal to 200, what was it, minus the width over 2. This means we either hit exactly the top wall or we're trying to go past it. We want to move the turtle back inside to the top wall now, so it's 200 minus width over 2. And we want to change the offset so that we move downwards now, because the offset was positive, moving us up to hit the top wall. Now we want to negate it again, same code, but it'll make us move downwards. Does that make sense? Like, did we see why that's necessary? Like, the turtle used to be like here, the offset was positive, so we kind of like did this. The turtle wanted to go here, but that's too far outside. We want to rein the turtle back in first of all, make him just graze it, and then make the offset negated so that he moves downwards next time. That's the idea. So that, in general, just repeatedly do all this in DrawFrame. That will give us animation. That will give us pretty much what we want. Off the bottom, off the top. And that is just so satisfying, I think. So let's walk through this. So what we do at the start was we drew this outer rectangle using our draw rectangle function. That was our bounding square. And then we made the turtle the ball, which is cute that we could do that. We change his shape to circle. We change his color. We stretch him. And then I had to do the heavy lifting last time, but apparently his width is 40 when you stretch him like that. It used to be 20. And then we're going to use these variables to keep track of where we want the turtle to be. Like, the x coordinate of the turtle should always be 0. It's just going up and down the x equals 0 line. But the y changes. The y starts out up top, the topmost spot, which is 200 minus the width over 2. And the offset is what's going to move the turtle each frame. Every time we call goto, we give a new y coordinate to the turtle that involves the old y coordinate plus the offset. And so if the offset's large, the turtle will move fast. If the offset is small, the turtle will move slow. If I make this 5 again, the turtle's going to be bouncing around super fast because he's moving 5 units every frame, every time we draw a frame. So rapidly moving turtle versus slower moving turtle when it's just 2. So that's that. What else? And so then we use the turtle as the ball. And so we never make him have any marks anymore. So he's like constantly in the up state. And then we give him a starting point. We tell him to go there. And then forever, while true, infinite loop, we draw the next frame. And so draw frame takes care of the heavy lifting, which involves moving the turtle slightly and then redrawing. All right. So moving the turtle slightly involves moving by your offset. Make sure to not hit a wall. If you ever try to go past the bottom wall, go back and touch the bottom wall and then change your offset to go up now. If you ever go past or hit exactly the top wall, then make sure you're exactly hitting it. Don't ever let the turtle go outside. And then set the offset to be inverted so that you move downwards now, because it was a positive offset to move you up. Now you want to move down. And so repeatedly just run this a bunch of times. That will produce this beautiful animation. Yay. Are there any questions about this? This is definitely a program that I want you to study. It's very cool. I think it has a lot of potential for you to play around with. Are there any questions about what we have right now? All right, please play around with this. It's fun. I promise to add some physics so that it actually looks like it's bouncing, because like when a ball bounces, gravity moves it down fast. It's not just a constant speed. And it kind of like boop, 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 and then it like eventually settles. So I will eventually add physics to this. I promise you that. And then I guess the last thing that I want to do is, the x is kind of hard-coded at 0. That's not too fun. Let's maybe make the starting x coordinate random so that we get some practice with random. Yes, that'll help us for the future, I guess. And so let's pick a random starting x coordinate for our turtle, just to make it a bit different every time you run the program. And so import the random library. And then the turtle's starting x coordinate could be whatever I want instead of 0. So let's be like, I don't know, random.rand int between -100 and 100. Now the ball might be in the perfect middle, might be a little to the left, a little to the right. It'll just follow along that line now. Again, the x never changes from here, but at least we give it something interesting to start with. And so now this time, where's the x? Oh, he's a little to the right, or sorry, to the left. And going to bounce and stay along there. If I rerun it, of course, the randomness makes it all change. That wasn't super random. That's pretty much the center. Let's see if we can get to the right of the center. All right, it just wants to stay on the left side, apparently, but you get the idea. Make a random x coordinate. And I think that is all that I wanted to show you. Still good with all this? It's a very fun, beautiful program. Please play around with it. Let's see here. Yeah, if we're happy, I think that's all that I wanted to show us as far as code today. It is the first lecture of a week. It's very surprising that it's a programming lecture. I blame the holidays that we had a long time ago, I guess. The first thing that I want to do now, or the final thing, I guess, today, is your last assignment. Your last assignment, it's going to be due the last week of classes, so let's see here. That's this week, the 8th through the 12th. So that's going to be due what? The 9th, so the normal, the Tuesday. But this will be due the last week of class. This is your last essay. Finish strong. We made it. So this will be due week 17, last week of classes. It will be one last essay, 1,000 words to finish us off. We are required to write 5,000 words this semester for some horrible reason. You can do it. You can do it, and then I can grade it. We'll be done soon. All right? So here is your prompt. It could be about anything. Go crazy. Write an essay. Write the essay that you want to write for this class. All right? So, okay. So, what do I want? Build your own essay. You can write about anything. Some topic. Choose a topic related to computer science, of course, computing technology or the internet that interests you. And this is the critical thinking class. And the topic is interesting, and it has some social or ethical implications that you can expand on and analyze. All right? So you can pick whatever topic you want to write about, as long as it's relevant to the class, with this in mind. The topic cannot be similar to previous essays. Can't rewrite the same essay. That's not fair. Can't rewrite an essay that you used in another class. That's not fair. So what I would like you to do is, pick whatever you'd like, whatever topic that's relevant that you'd like to write about that we didn't talk about in a previous essay. Could be something that we talked about in class, though, as long as you didn't write about it already in another essay. So what I want you to do, take that issue, whatever it is, analyze it. Pick apart both sides, the pros, the cons, talk about any assumptions that people are making, talk about any fallacies that are like behind maybe one side of the argument, one side of the issue, whatever it is, whatever topic you choose. Analyze it in terms of ethics. Maybe it's an ethical dilemma. talk about what Kant would think, what Mill might think, whatever you like. So I want you to have fun with this, finish strong. It's 1,000 words that I want you to write, and since it is a topic of your choosing, hopefully the 1,000 words will come a bit easier than usual. And this is definitely a research paper, so I would like you to do some research on whatever topic you choose, and please cite 4 works minimum, all right? So that's pretty much it. That is your requirements, all right? 1,000-word essay on whatever you like, as long as you didn't write about it already. Do the last week of class. Any questions about that? All right, that's your last essay. I guess the final will also have an essay. We'll talk about the final next week, but that's the last essay that is not part of a test. And yeah, with that is everything that I want to talk about today. The rest of the time is all yours.